Hello, welcome to the fourth part of the Siemens PC 100. If you haven't watched the previous parts, you can find the appropriate links in the description. In this video I am going to show some ROM functions. Let's start with the first one, reading a key. A good practice to test some function is presetting the registers with some values before you call this function. This is useful if you don't know which CPU registers will be changed. In part 1 of this video series, I've explained the monitor program. Just a quick review, the key R shows the registers. R, program counter, flag register, accumulator, X, Y, and stack pointer. Let me put 11 in accumulator, 22 in X, and 33 in Y. Okay, let's put program in memory address 200. The subroutine, the function E93C, will wait for keyboard input and put the ASCII value in the accumulator. E93C, a break, and let's launch the program. Hit the key 0. Check the registers, and accumulator has the value 30, which corresponds to the ASCII value of 0. As you can see, the function has only changed the accumulator. X and Y are still the same. Let's try another value. Let's hit H. And H should be 48, I don't know. Let me check on an ASCII table. Well, H, yeah, 48 hex value. And 0 was 30. As you can see here in the table, the ASCII value for the numbers are from 30 to 39. So if you subtract 30 from the ASCII value, you will get the corresponding decimal value. Let's advance the program and subtract 30 from the accumulator. Let's do it. Line 203. The 6502 only knows one subtract command, which is subtract with carry, so we have to set the carry flag first. Set carry, subtract carry, and the value 30. Let's do a break. Let's try the program. 3, register, and there's 3 and not 33. Another test. 0, 0, last one, 9, 9, and there's 9. There is an easier way to do this. The function is called convert ASCII to hex. Let's try this. 203, jump subroutine, and it's EA7D. EA7D, and the break. Okay. 5, and there's 5. And this function too does only change the accumulator, not X and not the Y register. Last one, 4. and there's 4. The next function is a character out. It's at the address EF05, and let's add a read key just behind. Otherwise, it will erase the display. Its reading character is E93C. E93C and a break. So, change the value A, 35, which corresponds to 5. Start the program, and 5. That's ASCII value 66. And 66 is nothing, doesn't know it. The ASCII value would be 66. 66. Oh yeah, would be a lowercase. Yeah, lowercase character. The computer doesn't know lowercase characters. So we have to use an uppercase character, 4D. 4D should work. It's an M. 4D is an M. That's correct. And there's also an opposite function, and to convert numbers to ASCII format. That's jump subroutine, and that's a function EA46. EA46, and let's do a break. Okay. Let's have number 05, and the result should be 35. That works too. There is another handy function. This is called readByte. Okay, jump subroutine E3FD. E3FD. Let's do a break. And this function waits for a number input. 0, 1. Register is, the accumulator is 0, 1. FD, the accumulator is FD. So this is a handy function, reads a number and converts converts the ASCII value to the hex number. In this example, I want to enter 2 hex numbers and print result on the screen. So, for example, I want to add 0A plus 05 equals, that's a 0F. So I want to show the equation like this on the LED screen. So let's do it. So on the first line, we're clearing the screen with the function EB44. Then we're reading the first hex value from the keyboard, storing the value to the memory 4 times O. Then I'll load the accumulator with the value 2B, which is actually the ASCII value for the plus sign. Then on the next line I will print out the plus sign, and here we're reading the second byte. transferring the accumulator to the X register just to save the value in the accumulator. Here I'm calling a subroutine E7D8, which will print the equal sign. Then restoring back the accumulator, clearing the carry, adding the value from the memory address 4 times O to the accumulator, and if there is an overflow, a carry flag set, in this case branch carry clear, there's no overflow, he will jump to the address 221. The branch carry clear flag does not take an absolute address, it's just a relative address. Here there are 7 steps. This is 0, 1, 2, 3, 4, 5, 6, 7. So it will jump to 221. But on this line assembler you can specify an absolute address. It will be converted to a relative address. And 221, he will convert the number in A to an ASCII value. And finally we're doing wait for a key. And if there isn't carry overflow, we're saving the accumulator again, putting the value ASCII value 1, which is 31, to the accumulator, printing out the 1 to the display, and restoring the value from the X register back to the accumulator, and print out the result and waiting for a key. Okay, let's enter the program. Subroutine B44, subroutine 3FD, storing to memory address 00, LDA immediate to B, jump subroutine EF05, and jump subroutine 3FD, TAX, jump subroutine 78, and transfer X to A, clear carry, at memory address 00, branch carry clear, and here we can specify the absolute address 0221. So X LDA 31, jump subroutine EF05, transfer X to A, jump subroutine EA46, and jump subroutine E93C, and finally a break. I want to break, I will do a jump to the beginning of the program. Okay, fingers crossed, let's check. 0A plus 05 equals 0F. Excellent. 11, 22, 33, F0, and 1, 2, 3. I can't remember if I showed you the programming of the function keys. Let's put, if you press F1, you will jump to the address 010C. 01OC, and there we're doing a jump to the address to our program, 200, and at the address 227 we have to put a return from subroutine. If you press F1, it's actually calling a subroutine, and in our program, return from subroutine will exit the function. So if I press F1, it will jump to our program, 1166, F1, 22, 55, F1, 00, 00. Okay, that's it, what I wanted to show you. I hope you enjoyed the video, and bye bye.